day everyone. Today, me and my group will discuss the topic about optimizing and controlling processes through statistical process control. I hope you all listen as it is very crucial to get knowledge from this subject. SPC or Statistical Process Control. It is a process that is widely used in the industry to measure and manage quality throughout the manufacturing process in order to facilitate ongoing improvement. The following variables influence how conformal or non-conforming the procedure is. Quality of conformance. It describes a manufacturing state in which the product completely complies with the plant's specifications. Chance variation or random variation. It addresses manufacturing situations where natural factors affect product variations. Older machinery often leads to more variability in output compared to modern machinery with design improvements. Assignable variation or non-random variation. It describes a production scenario where product variation results from identifiable issues like substandard materials, mishandled equipment, or human errors, which can be recognized and corrected. So, the following justifies the use of statistical process control. Continual improvement. Continuous process improvement leads to better goods and services, which is the goal of statistical process control. Predictability of process. Establishing production standards that lead a repeatable, predictable process that satisfy clients' needs is the goal of statistical process control. Lower cost of goods. The goal of statistical process control is to reduce waste and maximizes resources in order to reduce production costs, which in turn lowers the cost of items produced. Sampling and auditing. The goal of statistical process control is to reduce production variance and eliminate it, which lowers the cost of company's quality assurance, team audit, and inspection. So, the control charts. A control chart is a visual representation of time-ordered sample data used to monitor variations in output during a production process. It includes upper and lower control limits such as UCL and LCL to distinguish between random and non-random variance. If data points stay within these limits, the process is considered compliant. The variations may indicate potential fluctuations leading to inconsistent outcomes. So, next slide please. This is an example of a control chart.
The various application of control charts in organizational settings and across various departments within an organizational are as follows. In industrial settings, control charts quickly identify equipment malfunction in the industrial sector, enabling timely replacement and maintaining high output quality. Without them, factory malfunction can lead to mass production of defects, causing waste and customer dissatisfaction. In non-profit organizations, the control charts are helpful in charity and other organization campaigns. Since they are made to encourage job efficiency, it is simple to identify when an online contribution system goes down by using a control chart. For example, a little slowdown on the official website of certain charity might prevent important donations, leading to a campaign failure and disgruntled recipients of the organizational services. Budget. Control charts assess a company's monthly expenses. If spending surpasses 15% of the 20% budget cap in a quarter, it is crucial to cut costs. Alternatively, if the business allocates less than 8%, that extra funds can be used for equipment maintenance to foster continuous progress.
Retention rate. Control charts can monitor a company's human resource department retention rate. If retention surpasses or falls below control limits, signals potential bias in evaluation. Drop below lower limit prompts increase recruiting resources to bring retention back to the standard control level. Customer surveys can be monitored using control charts, helping businesses proactively manage feedback. If survey results are within the typical control range, business knows it's performing well and can focus on maintaining or enhancing those aspects. If results fall below the lower control unit, it signals the need for improvements to bring the survey back within a normal control range.
Implementation and deployment of SPC. Step 1. Commit to SPC. Since the adoption of SPC necessitates financial outlays, the use of human resources, a shift in the organization's culture, and the acquisition of personnel with new competencies, senior management must provide their full support. Step 2. Form an SPC committee. A cross-functional team led by the senior management is required to supervise the application and operation of SPC inside the company. Representatives from several areas, including engineering, finance, manufacturing, quality assurance, and statistics, must be on the team. Step 3. Train the SPC committee. The SPC committee needs to get fundamental statistical data training from upper management. The committee members will then possess the necessary knowledge to establish goals and choose which processes need to be addressed first. Step 4. Set SPC objectives. The SPC committee is required to establish the program's goals with the assistance of a consultant. The goals have to be predicated on a desired standard of success that includes reduced manufacturing cost, waste reduction, and positive customer feedback. Step 5. Identify target processes. A few pilot processes must be chosen by the SPC committee in order to start SPC off. Once enhanced, these procedures must have substantial effect on the organization's overall performance and be reasonably simple to control. Step 6. Train appropriate operators and teams. It is imperative that the SPC committee and management collaborate to offer comprehensive training to the operators and teams responsible for collecting, analyzing, and interpreting SPC data. The usage of flowcharts and high-quality tools must be included in the training.
Implementation and deployment of SPC. Step 7. Ensure repeatability of methods. All of the measuring tools that will be utilized, from straightforward calipers to intricate micrometers, must be appropriately approved and calibrated by the in-house specialists to assure reliable data collecting. Step 8. Delegate responsibility to the operators. Since the operators are actively involved in the process, the management must assign them the job of maintaining SPC control charts and gathering and visualizing data. Step 9. Flowchart the process. The whole production process must be graphically represented by the SPC committee and the operators. The inputs, outputs, and any intermediate stages between each process must be included in the graphical depiction. Step 10. Eliminate the special causes of variation. The SPC committee needs to create a cause and effect diagram listing all factors influencing manufacturing output. The intercompany, from top management to operators, must collaborate to identify and eliminate these factors causing production variations. Step 11. Last but not the least, develop control charts. The right control chart, which will be used to monitor the various processes in the manufacturing process, must be created by the in-house specialists. This is to guarantee that the root causes of output punctuation have been completely removed and that the right actions are being done every day. So that would be all. I hope that viewers will learn from us, and thank you.